Hello everyone, a warm welcome to our case study Resource-Efficient Wastewater Treatment, System Analysis of the Wastewater Treatment Plant Liebenwalde. I'd like to invite you for a short stroll over the wastewater treatment plant. During this stroll, you will be confronted with a lot of challenges that may also be present in your plant. Before I start with my presentation, please let me introduce myself. My name is Markus Leidinger and I'm responsible for the application management at the AERZEN Maschinenfabrik. With these references, ladies and gentlemen, I would like to tell you the story from the ugly duck to a brilliant swan. And therefore, let us go straight to our international reference, the wastewater treatment plant Liebenwalde in the east of Germany, not far away from Berlin. At first, let's go into the past. In 2018, we found a plant in very poor condition. Liebenwalde was one of the worst wastewater treatment plants regarding energy efficiency, and the plant had no money to change it. Let us look now to the operating data in 2018. The energy consumption of the entire plant was 560,000 kilowatt hours per year. The plant manager faced a capacity increase of 42%. This was a mission impossible. Why? The oxygenation in the aeration basin was only 0.5 milligram per liter. However, the required value was and still is 1.5 milligram per liter. These bad values came primarily from an old and defective pipe membrane diffuser aeration system combined with an old uneconomical blower system. The energy evaluation of the plant was extremely bad, with 42 kilowatt hours per population equivalent per year. In summary, a very big challenge. What was the solution? Together with an expert company for grant application, we were able to regenerate a funding program. Within 3 years, 3 different treatment processes were completely rebuilt. We started in 2019 with a new fine bubble aeration system, inclusive new rotor piston compressors, a second quid chamber and 2 new rakes. The investment cost amounted to 700,000 euro. We got 80% funding for this project and this corresponds to 550,000 euros. In 2020, a new sludge humidification plant was built. Costs 2 million euro and 1.6 million euro was funding. 1 year later came the photovoltaic system with costs of 220,000 euro, and so we were able to optimize the plant with a charming funding program of 2.5 million euros. My presentation is focused on the reconstruction of the aeration systems. And now, ladies and gentlemen, I would like to present you the optimization in detail. Here you can see an aerial view of the plant Liebenwalde. We are focused on point 4, the old blower house, number 5, the new AERZEN container solution, and 6, the aeration tank. Let me start with some general information from the wastewater treatment plant Liebenwalde. The year of construction was 1992. The plant had a capacity of 14,000 population equivalent. The aeration basin had a volume of 5,400 cubic meters with a water depth of 3.9 meters. The polluting load is lying by 630,000 cubic meters per year. We have an oxygen set point at 1.5 milligram per liter, and the big challenge was the 42% capacity increase due to drugs deliveries from the neighboring communities. Now let's go into the past. Here you can see the previous operating mode in the old compressor room. 3 old blowers, 30 years old, deliver intermittent the air into the aeration basin via an old pipe membrane diffuser. The installed power for each machine was 18.5 kilowatts. We had a volume flow of 950 cubic meters per hour per machine and the pressure difference was 520 millibar. All machines run together 15 hours in full load operation mode. The right picture presents you the old installation. Above the blowers and below the pipe diffuser. There were many disadvantages with this old aeration system. The pipe membrane diffuser were inefficient and partly defective due to aging. You can see this in the turbulent water surface in the aeration tank. The old blowers were uneconomic and they were equipped without frequency converter. All these circumstances were responsible for a bad oxygen value of 0.5 mg per liter. It was very difficult to get new spare parts due to aging of all components. In terms of energy efficiency, we had high pressure losses because of long pipelines up to the basin. The complete system was uneconomic and 42% capacity increase was so not possible. So the customer decided for a completely new aeration system, which you can see in this slide. We placed 2 delta hybrid machines in a container solution as close as possible to the aeration basin. In this way, we avoided unnecessary pressure loss into the pipe systems. Via a collecting pipe, the air entered the aeration basin in intermittent evaporation. Inside of the basin, we have installed a fine bubble membrane aeration system. Now let's take a look at the performance data of the new AERZEN container solution. In our container, we packed 2 delta hybrid D52S machines. Both machines have exactly the same performance data. The machines are configured for a volume flow between 800 up to 2500 cubic meters per hour. The installed power is 55 kilowatts per machine and the pressure difference is only 450 millibar. The machines run in frequency converter mode 13 hours per day. The container solution saved considerable costs in terms of CapEx and OpEx. Let us look to the installation concept. The station was built as close as possible at the aeration basin. In this way, we were able to guarantee the lowest pressure loss in the pipe system, and everybody knows pressure loss costs energy and money. A short pipe system to the basin reduced the material cost and the pipeline costs. We don't need a new compressor building, and with the outdoor installation, we have the best possible oxygen input into the biology. The conveying chamber of the machine is 100% oil-free. Our sound absorber has no absorption material, and therefore we avoid a blocking of the aeration blades from inside over the years. With all this action, we could realize cost reduction of more than 200,000 euro. Here you can see now the energy comparison between the old compressor system and the new compressor systems. So let's take a closer look at this diagram. The energy consumption in kilowatt via two process is shown on the y-axis. On the x-axis, you can see the running times of the machines per day. The brown curve shows the running time of the old compressors with 15 hours. Blue is the curve progress of the new compressors. Two things are very important. The new machines run with frequency converter. The control unit is able to decide whether 1 or 2 machines need to run. With the old solution, the only option is to start or stop all 3 machines at the same time, and the aeration process is 15 hours. Everyone can see the new solution brings significant energy cost savings. How much can you see at this picture here? In 2017, the plant required 294,000 kilowatt hours of energy. With the new solution in 2021, only 160,000 kilowatt hours were required, and that with 42% increase of capacity. This means we can save 47% energy, which is equivalent to 30,000 euro per year. Ladies and gentlemen, we have now come to the end of my presentation. Here you could see all advantages at a glance. First, 47% energy saving by 42% capacity increase. Second, 80% funding of the plant investment costs. Third, energy saving of the entire plant 65,000 euro per year. Fourth, new installed solar power with 130,000 kilowatt hours per year. Fifth, top value of 17 kilowatt hours per population equivalent per year. And sixth, 210 tons of CO2 reduction per year. This, ladies and gentlemen, is the AERZEN contribution for a worse living world. And therefore, let us go together to the right side of life. Now, it's a great pleasure to me to present you the movie of the wastewater treatment plant Liebenwalde, winner of the German ENSI Award. Please enjoy the movie. Hope see you soon again.
Energy costs have increased by 100% in the last 10 years. Water management represents 35% of municipal energy consumption. Liebenwalde in Brandenburg. A typical sewage treatment plant. This plant treats the sewage from approximately 15,000 residents. The facility is operated by TAV Liebenwalde. To save energy, the company decided to replace the blower and biological aeration system. The equipment supplier, AERZEN Maschinenfabrik, advised the company to begin by consulting the EQUA network about energy issues. EQUA is an independent institution in the water industry that has advised municipal operators in over 120 energy projects. Its target for wastewater treatment plants, an annual energy consumption of approximately 18 kilowatt-hours per resident. A quick test of the Liebenwalde sewage treatment plant calculated 42 kilowatt-hours per resident per year, more than twice the target. Accordingly, EQUA recommended that TAV Liebenwalde commission an in-depth energy assessment of its plant. This served to identify all energy potentials. It was also a prerequisite for obtaining state funding for investment activities. EQUA provided the following services as part of the process. Support of the funding process to obtain 50% state subsidization for the energy potential assessment. Support of the energy potential assessment to achieve short, medium, and long-term reductions in energy costs and greenhouse gas emissions. Preparation of a catalog of measures, including a funding strategy for the expected investments. The results of the assessment were clear. Increasing energy efficiency and utilizing renewable energy sources would offer significant potential for reducing CO2 emissions. 3 specific measures were implemented. 1. Optimization of the aeration system and the aeration tank by using efficient compressors and plate aerators. Through the use of the modern and efficient Delta hybrid rotary compressor, we have succeeded in reducing the energy requirements of the aeration system by 47% in combination with the new aeration system. The advantage of this system is the highly efficient oxygenation process. 2. Construction of a sewage sludge humification plant. This new humification plant will enable us to achieve a total solids content of up to 40%. That will reduce the subsequent transport overhead by approximately 90%. 3. Construction of a 100 kilowatt peak ground-mounted photovoltaic system with battery storage. It consists of 134 modules which produce 110,000 kilowatt-hours per year. This corresponds to 1/3 of the sewage treatment plant's energy requirements. All measures were supported by the REN Plus 2014-2020 funding program for reducing energy-related CO2 emissions, providing subsidization up to 80% through a grant from the European Regional Development Fund and the state of Brandenburg. Thanks to this collaboration, the energy savings target defined by EQUA was achieved. That represents a combined energy and greenhouse gas emissions reduction of more than 50%. That makes an energy savings of 60,000 euros per year. Even after implementing all the measures, EQUA continues to support TAV Liebenwalde, along with numerous other providers throughout Germany, in all matters concerning energy and public funding via one of its regional energy efficiency networks.
Thank you, Markus, for the impressive practice example. In the presentation of my colleague Markus Leidinger, you learn how machine upgrades and intelligent machine control can significantly reduce energy consumption. My name is Arndt Ohme and I am Business Development Manager at AERZEN Digital Systems. and I would now like to show you how digital services can provide you to optimize the machine maintenance with more transparency and intelligent machine data analytics. Let me start with a few answers that I hear often from customers when we talk about machine maintenance. One of them told me that to get an overview of the conditions of the machine, I have to go to the machine on site. Since I have a lot to do at the plant, it happens again and again that the time is too short to check more often the machine. Another customer said to me, the maintenance is time-based at the plant, independent of the operating hours and the machine load. It happens that the machine are not so heavily loaded that wear parts are replaced even though they are not yet worn out. Another request is, in the event of a failure, I receive a collective failure message in the control station. To find out the details, I have to go to the machine on site, and this takes time. On the other hand, we document the maintenance work on paper and file it in a folder. Very old school. Another request that I get is, in the event of a failure, we sometimes spend more time looking for the case as we do not have to detailed machine data records. Do you recognize yourself? When we take a look at preventive maintenance, the goal here is to replace components before they fail. And this is the most common maintenance strategy. Here components are replaced regardless of this condition, but based on the time interval. It does not matter whether the machine has high or low utilization. In wastewater treatment plants, the blowers do not run permanently and also with different loads. This result is different wear than with blowers that run permanently under full load. For this, usage-based maintenance is more suitable here than as preventive maintenance. The graphic that you can see shows the comparison between preventive maintenance and predictive maintenance. Especially for machines that do not work permanently with the same load, predictive maintenance results in an optimization of the maintenance interval based on the condition of the machine. Especially when the machine load is lower and the operating hours are less, the maintenance intervals can be optimized as needed, with the result of cost savings. By collecting machine data together with data analytics, the optimal time for maintenance can be defined much better. Furthermore, there are less undiscovered cases of higher wear and tear. With our product AirProgress condition monitoring, we collect the machine data like pressure and temperatures together with the vibration at the bearing of the stage and the engine. This data is analyzed with modern algorithm and the health index of the machine as a whole and individual wear parts are calculated from it. What does it look like in practice? As shown in the graphic, the pressure and temperature data as well as the operating hours came from the machine control system, the electronic. With additional vibration sensors at the bearings of the stage and the drive motor, the bearing vibrations are measured in details. This data are sent to the AERZEN cloud via the AERZEN IoT gateway using mobile communications. In the cloud, the data is stored and analyzed with modern algorithm. You as the user has access to the data and informations via a web interface by using a web browser. The data communication and the access is secured by using high-level cybersecurity mechanism. As a user, you can easily access the AERZEN digital platform with any web browser and your user account. Via the digital platform, you also receive information when limit values are exceeded and information about the health index of the blower and the relevant wear parts. This allows you easily and quick to get an overview of the condition of your blower at any time from anywhere. The following screenshots shows the view in the digital platform of these topics. The first screenshot shows the process data as current value and as history in the diagram. The next screenshot shows the vibration value of the bearings in a diagram time-based. The next screenshot shows the event log in the AERZEN digital platform from the machine with the possibility to subscribe to email notification in cases of an event. So you get directly from the system an email notification when the relevant information to solve the problem. And finally, a screenshot with the health index of the whole machine and important parts like the air filter and the different bearings. This health index is very smart. In the background of the digital platform, there are running complex and intelligent calculations. They calculated permanently by our intelligence data analytics algorithm based on the received machine data. With these, you get a clear overview about the health of the machine. With this information, you every time clear and easy to understand information about the condition of the relevant components of your machine. With these informations, you can optimize the maintenance very smart. You have learned about the various functions of the AERZEN platform condition monitoring, and now I would like to show you the saving potential that results from the optimal maintenance with the example of an air filter. The example is based on a customer application on wastewater treatment plant with an D52S blower. In the past, the customer changed the air filter of once a year. The air filter was then, in this case, at the customer side, always very clogged, which means that the energy consumption of the machine continuously increased in order to work against the clogging. As a result, the energy consumption and also the operating costs increased accordingly. We updated the machine with a progress condition monitoring at the customer. The graphic shows the result. The permanent operating data analytics of progress condition monitoring showed that based on the clogging of the filter, a filter change 4 times a year is optimal. Also, the customer has higher maintenance costs. He has a reduction of total operation costs of 1,711 euros per year. This investment cost for their progress retrofit pays off after less than 3 years. Based on this fact, the energy prices are currently rising very sharply. The payoff is possible even earlier. The additional vibration monitoring of the bearings has so far shown that the bearings at the time of the time-based maintenance did not have a high wear. Therefore, replacement was not yet necessary, and the customer has saved additional costs for the maintenance of the bearings. Digital services and intelligent data analytics offer additional added value. They offer additional opportunities to reduce operating costs and increase the service life of the machine. Now it's time to take these advantages of this and benefits from the ease. I hope I could give you a feeling what can a progress condition monitoring do for you and what potential is in it. We are happy to support you in the implementation. Please do not hesitate to contact us if you have any questions. Thank you very much and see you soon. Ladies and gentlemen, the first part of the webinar is finished, and now we are going forward with the Q&A of our presentation. A lot of you ask a lot of interesting questions around our presentation, and now we start with the first questions. Markus, you are ready for the first question?
Yes, of course, we can start.
Okay. The first interesting question is, how's the procedure to get state funding?
Let us start with Germany. Here in Germany, you need a potential analysis at first. Then follows a concept study. This study includes which treatment process have high potential to save energy or CO2, and what concrete replacement are required. Then you can apply for state funding. My experience tells me the processes are similar in every country. It is important to know whether there is a state funding. That is the base.
Okay, yeah, very interesting. And yeah, the next question is, why didn't the customer in the presentation decide for turbo blowers?
Also a good question. In this case, at the wastewater treatment plant Liebenwalde, using 2 delta hybrid machines was the better solution. Reason number 1, with the delta hybrids, we can realize a wider volume flow range, and via this flow range, we really have a good energy efficiency. Both things was very, very important. Reason number 2, in this case, we could install the power and control cabinet from our machine, inclusive the frequency converter, in an existing building. This was the significantly cheaper and better solution for the requirement treatment process.
Okay. Yeah, another interesting question is, do you produce a container solution at AERZEN Maschinenfabrik?
I have to say, yes, of course. We are able to deliver a complete container solution with all needed components. This includes the machine, of course, the power and control cabinet, inclusive frequency converter, the room ventilation, the pipe connection, and the digitalization as option. We can say we deliver a complete plug-and-play solution for the customer.
Yeah, very interesting. Hand in hand, working together. That makes sense. Yeah, the time is running very fast, and I think it's time to change the Q&A to my topic. And Markus, would you please take a look at question side, questions about my topic, and I would like to answer this.
And I can say I'm really surprised. I can see digitalization is a big topic for our customer. I have so much question for you. I'm thinking I will look what is the most interesting questions, and let me see. I'm thinking this question is also good. Is AirProgress also available without cloud?
Yeah, that's a interesting question that I very often hear. So the actual situation is we are focused on cloud solution, because the cloud solution gives us a lot of opportunities and a lot of advantages against solution that is only placed on site by the customer. The big advantage is, especially when all the data came together in our cloud application, and there the data will be used for our automation, machine learning for optimizing the complete analytics process and so on. And there we have a lot of benefits for our artificial intelligence. And when you have only your few machines that are used for training the artificial intelligence for the analytics algorithm, then there is not so many powerful learning processes possible as when you have more than your machines. And so this is the reason why we focus on cloud application, and we think that the cloud is the best solution for this topic, especially when we're talking about data analytics, machine learning, and a lot of artificial processes in the background.
And here I can see a question. She is asked very, very often. Can the data also be linked to a SCADA system?
Yeah, that's true. And this is a question that I get often from customers too. Yeah, SCADA system is a topic. There are a lot of different SCADA system in the market and different interfaces. And currently, we are offering the Modbus TCP as a standard interface, and another interfaces are coming in future. And but in practice, it shows us not every connection is the same connection, and the interfaces are often different. And so there is a point where we have to take a deeper look in the interface of the SCADA system. And so it's then a decision that we can do on site when we have more details from the SCADA system that is used.
And thank you so much for your answer. And now, ladies and gentlemen, I'd like to come to the last question in this webinar. And this is a big, big topic. I'm thinking, Sir, this is also a question, but you get very, very often. We're talking about hacking attacks. Can a hacker manipulate the machine via the cellular connection?
Yeah, this question very often, especially when we are talking about wastewater treatment plants and application that have special policies around IT security and cybersecurity. And during the developing process of our product, we are very strong focused on this topic because this is the main issue that we have to solve, and so directly we developed product and transmission and communication protocols that are very secure, and it's based on the CRITIS application and based on the international ISO 62443 applications. And so we have a very secure application that is state of the art of cybersecurity and IT security. And on the other hand, we have some special things done, especially in the IoT gateway. The communication, when we are communicate the data in the cloud, is transmitted encrypted, and so we have there the possibility to bring the data safe to the cloud with not really chances to decrypt this data. And on the other hand, we have a gateway. It works like a firewall. It blocks wrong and critical accesses from outside. And then as an additional security functionality in the current standard version of the IoT gateway, it's not possible to control machine from outside remotely over the IoT gateway. So the IoT gateway blocks directly reading processes and writing processes. That's not directly so in the process implemented.
Thank you so much for your answer, and I can see this is a difficult topic, and it is not too easy to avoid the complete risk for the customer. From my experience, I can also say very often I have a lot of questions to exactly this topic here. And ladies and gentlemen, now we are in the end of our presentation. We received more than 20 another question, but it is not possible to answer all these questions in this time. But I promise you, we will collect all these questions and then we send you an email separate with all information what do you need. Thank you so much for your attention. I hope it was very interesting for you. Hope we see us soon again. Bye-bye.
Yeah, from my side, thank you very much for participation and see you soon. Bye.